So it says show that vector v, and I'm going to talk about this notation here for a second. So I've got the little arrow above it to indicate that it's a vector. The other notation is to have a bold v like this, not italicized. Most textbooks use one of those two notations. I notice in your book, though, they just use an italicized v to indicate, not in bold, to indicate that it's a vector, just so that you know. Okay, so show the vector v with initial point and terminal point is equal to u, vector u, with initial point and terminal point. Draw a position vector on the same grid as v and u. Next, find the magnitude and direction of each vector. Okay, so there's really a lot going on here, but let's look at the point 5, 3, 5, negative 3. So 5, negative 3, we're saying that's an initial point, and then it has a terminal point at negative 1, 2. So we get this vector going like this, and we would call that vector v. And hopefully it's, well, it's not straight, but it should be straight. Okay, now vector u has an initial point at negative 1, negative 3, and then terminal point at negative 7, 2. Negative 7, it's kind of off my grid here. 2. We'll say it's there. And let me put it in a different color. Okay, and that's going to be vector u. And I think I mentioned that u and v are common names of vectors when we're working with them. Okay, now, if I wanted to find the position vector for v, so the position vector of v would be equal to, I would take the terminal point negative 1 and subtract 5, and then I would take the terminal point, the y on that point, 2 minus negative 3. And then that would give me negative 6, 5. Okay, so that would be v in standard position. Okay, so let me draw that. I'll draw it in green. So at negative 6, negative 6, 5, it's like right there. And so remember, one in standard position is going from the origin out there. Okay, now let's do the same thing with u. What did we do that in orange? So u has a standard position. I forgot to put the arrow on that. You can see it's kind of a pain sometimes to draw the arrows in. Okay, so we're going to do standard position, or the position vector for u. So we're going to say negative 7 minus negative 1 and 2 minus negative 3. And that's also going to give us negative 6, 5. So right here, they have the same standard position, same position vector. Therefore, vector u, or vector v, is equal to vector u. Because they have the same position vector, that means they have the same magnitude and the same direction. Now, if you look at the graph, hopefully those three vectors all look to be the same length, and they're headed in the same direction. Okay. They ask us to find the magnitude. Well, you're just going to use your position vector to find the magnitude. I would anyway. So you can say the magnitude of v, which is also the magnitude of u, is equal to the square root of negative 6 squared plus 5 squared. And that's going to be what? 36 plus 25, which is the square root of 61. 61 is prime, so you're done. That would be the magnitude. You could get a decimal approximation if you were interested. Now, to find the direction, you're going to say tangent theta is equal to 5 over negative 6. So you can put in your calculator inverse tangent negative 5 over 6. And let's see what we get. Let me grab my calculator. Let's see, inverse tangent. And it is negative 5 divided by 6. I'm getting it to be, oh man, I'm in radians. Let me go to degrees. All right. That all happens to us at some point when we mean to be in the one and in the other. Okay, so I'm in degrees now. Inverse tangent of negative 5 divided by 6. And we get negative, about, theta is approximately negative 39.8. But we're going to go ahead and add that. We know we're in our position vector right here is in quadrant 2, right? Okay, so we can take and add that to pi. And, oh, it didn't add good for me. Let me try again. Okay, that was like an operator error with the calculator. But you don't want to add pi, you want to add 180 degrees. I forgot we're in degrees. Okay, oops. So to get that, this direction, we're looking for this direction right here, this theta right there. What's that? And we're going to say that theta is approximately equal to, once you add 180 to this, 140.2 degrees. And I think that's all they want. We've drawn everything. So that's it for that one.